Hello, welcome to today's session. Today we will be talking about the concept of transportation geography and the concept of graph theory. We will be talking about the various terms in the graph theory and the various relations and connections between the graph theory. So let's start with what is transportation geography. Transport geography or transportation geography is a routinely used term in most of our day-to-day processes. Whenever we talk about any concept spatially, it falls under the ambit of geography. So that means if we are trying to understand transportation between location A and B, for example, that would be covered under the concept of transport geography. Okay, so under this, what we can spatially understand here is there are few important concepts. First is the freight or the number of the amount of weight that is moving on from point A to location B. The second here is number of people, and third is number of interactions. So interactions can be between A and B, that is a linear interaction. Then there is this path, this path. So there can be various forms of interactions by which A and B are connected. Then the common activities or economic activities between the region are the reasons for connectivity between points or city A and city B. So when we talk about transportation geography, we must understand that through the civilizations or historically, the transportation has grown and developed, and there were important centers in every region that started to get connected. Slowly and gradually, there were main transport arteries that were formed between those regions which were strongly connected, and there were less development or less arteries between the weakly developed regions. So the important impact of transportation is because of civilization. Then you have social and economic reasons because of which transportation has been taking place. Transport geography, under transport geography, broadly we include the various forms of transportation, that is railways, roadways, air transportation, transportation by ship or water transportation. Now, to understand the concept of transportation geography, there is one concept that we must try to understand, and that is the concept of graph theory. So let's start with what is the concept of graph theory and what is graph. So when we talk about the encoding and measurement of any network, that is what is graph theory. So it's simply a function of V and E, where V is the vertices and E is the edges. Now, if I say, let's take a very simple example. I have 2 points. One is Los Angeles, other is the city of New York. Okay, so these are the 2 vertices, and this is the edge that is joining the 2 vertices. So edge is also known as link, and vertices is also known as a node. Now, what is the size? So the number of edges that we are talking about is the size. So if I say there is just one edge that connects Los Angeles to New York, however, in practical situation, this is not the case. I'm just taking an example. So that would be the number of edges, and so the number of edges would be the size. Now, I'll understand the remaining term. I'll help you understand the remaining terms with this diagram. Now, in this diagram, as you can see, there is a green line which connects H, A, and B. So this is a kind of complete graph, we can say. H, A, and B. So this path, this points which connects H, A, and B is a path. Okay. Now there is a term called as walk, and there are 2 kinds of walk: open walk and closed walk. Open walk means if I start, open walk is basically a path. So I'm starting with H and moving on to B. So my starting point and ending point are different. So that's the case of open walk. The next is closed walk. Closed walk simply means if my start point and end point are same. So for example, if I go from H, A, B, D and back to H, so that would be a kind of closed walk. But again, if I take the same example, H, A, B, D, H, and from there I go to G and come back to H, okay, that's my final location. So that would again be a kind of closed walk. But in case of cycle or a simple cycle, what happens is there is no repetition of edges. So if I start with H, D, G, so let's take H, D, G and H, those marked in the red. So you have this, this and this. So what I'm doing, I'm coming back, starting and coming at the same point, but no repetition of the edges. So that is what is a cycle. Now what is circuit? Under circuit you have repetition of edges. Sorry, repetition of vertices. Okay. So here you can say I'm starting from D, B, C, D, E, F and back to D. So basically what is happening, D is a vertex that is being repeated. There is no repetition of H, but there is repetition of vertices. And this is what is known as a circle. So under graph theory, what we have tried to understand today is what is node. Firstly, node or vertex. Then we have talked about edge or link. We have talked about two types of walk, the open walk and the closed walk. We have understood the concept of cycle and circuit. So cycle and circuit, the difference is very important. Okay. Now, there are few things that you must know under graph theory, and those are the connections in the graph. So connections in graph. So first kind of connection is walk, we already talked about. The second important connection is tree. So tree is minimally connected graph, which implies that there is only one possible way to reach any point. For example, I mark point A, B and C. Okay. And then you have D. Okay. So there is only one way to reach to C and there is only one way to reach to D. So when there is a single way to reach to any place, that would be the tree. Okay. The next connection here is the distance. So distance is basically between two vertices. So this is vertex A and this is vertex B. So how far they are would be the distance. Then you have the length. So length is the number of edges. So length is basically how many edges are there between the various vertices. Okay. So that would be the edge. Then just come back to this graph here and I'll try to explain you the concept of chord. So if I draw a diagram here, okay, these points are connected to themselves, but point that is not directly connected would be the chord. So this is what is the chord. Now you have two important terms, that is the cut edge. Cut edge is also known as bridge or isthmus. Now what is a cut edge? For example, I have a graph here, okay, and say this is connected in this fashion. Now what would happen if I remove this edge? This point or vertex would get disconnected, and so this graph would become disconnected, and that is what is a cut edge. So this vertex becomes independent and disconnected from the rest of those. So removal of one edge disconnects the graph. The next is cut vertex. So if you have 3 points here, okay, and I cut this vertex or I remove this vertex, okay, what would happen is there would be a kind of disconnection in the subgraph. Okay. Now these were the general connections in the graph. Now let's talk about the next thing, is that is the structural property. So structural property of a graph. Under structural property, first is symmetry or asymmetric. Symmetry means all the edges and vertices are linked in one direction. So that is kind of symmetry. The next is connectivity. That means one vertex is connected to another vertex. Okay, that is connectivity. The third is complement. Now, what is complement of a graph? So let's say I have 3 points A, B, and C. And what I do is I copy this set again. So I have 3 points again here. Now, in the first graph, I have connections between A and C and B. So this is the first graph and this is the second graph. So if I'm trying to, so this is the complement of this graph. So this is the complement of this graph, okay? And what I do is, if I try to create a union of these two graphs, what would happen would be a kind of complete graph. So this would be A, B, and C, or a kind of complete graph. So these are the basic things that we must be clear about in the concept of graph theory. And graph theory forms the basis for transportation geography. Based on the graph theory, we would be further discussing in detail the concept of network analysis, connectivity, and accessibility. So stay tuned for further lessons. Have a good day ahead.